The end of an era was closing in. The shuttle program's last triumph, the International Space Station, was almost complete. The final substantial piece was the station's Alpha Magnetic Spectrometer, a $2 billion effort put forth by over 60 institutions across 16 nations to examine not only the origins, but also the composition of the universe we live in. The Alpha Magnetic Spectrometer was to be flown on STS-134, the second-to-last shuttle mission. President Obama and his family came to watch this historic launch. However, there was a failure during the countdown. A thermostat on one of the auxiliary power unit fuel lines was not responding correctly. If the redundant thermostat failed to trip heaters in flight, the fuel line could freeze, causing a crack. During re-entry, the increase of temperatures could ignite this fuel, causing the aft of the shuttle to catch fire. Real-time troubleshooting was performed on the flight deck, but the temperature readings did not improve, and the launch was scrubbed. The electrical and auxiliary power unit communities commenced with repair and troubleshooting plans immediately, while safing of the space shuttle and fuel removal were underway. The electrical groups used SMART and boilerplate steps to expedite the repair and troubleshooting. The first step in the troubleshooting plan was to exonerate the avionics box associated with the heater and thermostat wiring. To do this, engineers altered SMART procedures usually used for validation. Irregular voltage readings were found in the avionics box. It was subsequently removed and checked out. It was seen that there was a voltage spike on one of the drivers inside the avionics box. This, however, was not the root cause, but just a consequence of a much larger problem. In order to isolate the root cause, engineers used additional SMART procedures to visually inspect the wiring, to remove splices to isolate the system, and then to validate the wiring through testing procedures. The failure could not be recreated. Therefore, the team chose to install new wiring along existing cable runs. This was all done in conjunction with heater and thermostat checkout. The team was trying to return the vehicle to a safe configuration in a timely manner. Their launch date affected an Atlas launch, a Soyuz undocking, and the launch date for Atlantis, the final space shuttle mission. The most likely cause of the failure was found to be damage to a thermostat. As electrical lead for Space Shuttle Endeavour during the launch scrub, it is my belief that SMART saved me hours of work and allowed me to spend more time in the vehicle and at troubleshooting meetings and less time sitting at my desk writing paperwork. SMART was one of the tools that allowed us to launch a safe vehicle in a short turnaround time.
For the final launch of Endeavour, expanding our knowledge, expanding our lives in space.
Houston, Endeavour, all program.
Roger, roll, Endeavour.